All right, good morning, everybody. Taking a step back from algorithms and looking at more at the application side of math, get ready for lesson 57. We're talking about probability and chance. So, probability is a mathematical measure of how likely it is for something to happen. And you can measure just about anything, and you could either put it in a fraction form or a percent form. So if they're talking about probability, what you need to know is that probability is written as a fraction. Chance is a word that describes the outcome, and you have four chance words: impossible, unlikely, likely, or certain. And here's how they play out on a number line. If you had 0% or any fraction with 0 as the denominator, that means the chance is impossible. It is never, ever, ever going to happen. Anything bigger than 0 but less than 50% or a half, like if it's 1/3 or 1/4 or 3/8, that would be described as an unlikely chance. Anything more than 50% or a half, like 2/3 or 3/4 or 4/5, that means it's likely to happen. And anytime the fraction would end up as 1 when it has the same denominator and numerator, or if the percent is 100%, that means that the chance is certain. It is going to happen every time. And probability is used a lot at places like casinos. I mean, they actually mathematically study. You can go and see how many pennies are going to be paid on every single dollar bet. And people make whole careers out of analyzing these types of statistics. So let's dive right into it. Remember, we are going to have problems like this for the rest of the year. So we are going to have to make our peace with it. Take a look here. It says, if today's chance of rain is 20%, what is the chance that it will not rain today? And here's what you gotta focus on. What is the chance that it will not rain today? They are saying that there's a 20% chance of rain. So from 0 to 20%, that's your chance that it will not rain. That means the rest of this, the chance is that it's not going to rain. Well, if 20% is rain and there's 100%, it's got to be 80% that it will not rain today. Did you see how I did that? What is 100% minus 20%? Hey, that's 80%. That's where that number comes from. So I got 80%. What is our chance word? Well, it looks like it's going to be very likely that it's not going to rain today. I wouldn't feel bad if I didn't pack my raincoat with an 80% chance that it's not going to rain. Check out this one. And the thing that probably bothers me most about this book is that they refuse to use the word dice. They are going to say a standard dot cube. Huh? Well, a standard dot cube is a dice. I don't think there's any fifth grader in here who's never seen your regular die is the singular form of the word. So we know that 1 dot and 2 dots and 3 and 4 and 5 and 6 dots. Never seen a fifth grader who hasn't ever seen these before. But I do meet lots who go, Mr. Rhymes, what's a standard dot cube? Dice. Okay? So a standard dot cube is rolled once. Which word? certain, likely, unlikely, or impossible best describes the event that the cube will stop with 3 dots on top. Well, before you try to pick one of these words, you either better get it figured out as either a fraction or a percent, because you don't want to just go eeny, meeny, miny, mo. So the easiest way is to set it up as a fraction. And remember how fractions work. The denominator is going to be the total number of choices. So looks to me like I have a denominator of 6 here, because I could have a 1, a 2, a 3, a 4, a 5, or a 6. So my denominator is going to be 6. What is going to be my numerator? The one I am talking about will stop with 3 dots on top. Looks to me like I only have one of those with 3 dots on top, right? So now we better figure this out. 1/6. Is that going to be less than a half or more than a half? Hopefully you know 1/6. That's less than a half. So what's going to be the word that I use? 1/6 appears to be very unlikely that it's going to happen because it's less than 50% or a half, right? So if the outcome is less than 50% or a half, the chance is unlikely. Check out this one. A standard dot cube, a dice, is rolled once. Which word, certain, likely, unlikely, or impossible, best describes this event? That the cube will stop with more than 2 dots on top. There's our key word, more than 2 dots. So let's set it up as a fraction. What is our denominator if we're talking about a standard dot cube? Looks to me like I have 6 possible outcomes, so that's going to be my denominator. But how many of these guys has more than 2 dots? And this is where sometimes 5th graders mess up. Is 2 more than 2? No, 2 is equal to 2. But 3 is more than 2, and 4 is more than 2. 5 is definitely more than 2, and you know what? 6 is a whole lot more than 2 also. So how many choices do I have here? I have 4 is going to be my numerator, right? So I now have a fraction of 4/6. Well, I know 4/6 isn't 0, and I know it's definitely not 1. So I got to figure out, is 4/6 more than a half or less than a half? If you remember, look at the denominator. Half of 6 is 3, right? 4 is more than 3, so 4/6 is more than 1/2. So if I'm putting them over here, what is going to be my chance word? It is likely to happen if it's 4/6. How about this one? A standard dot cube, a dice, is rolled once. Which word, certain, likely, unlikely, or impossible, best describes this event? The cube will have fewer than 7 dots on top. Fewer than 7. So again, my denominator is going to be 6 because I have a choice of 6 different outcomes, right? Let's figure out what my numerator is. Which one of these guys has fewer than 7? Well, 1's fewer than 7. 2's fewer than 7. 3's fewer than 7. 4's fewer than 7. Oh my goodness, 5 is fewer than 7. And 6 is fewer than 7. It is 6/6. It is a fraction where the numerator and the denominator are the same. That means it equals 1, right? So What type of a chance word are we going to use this time? Looks to me like if it's a fraction equal to 1 with the same denominator and numerator, the chance is it's certain. It will happen every single time. How about this one? A standard dot cube is rolled once. Which word best describes this event? That the cube will have more than 6 dots on top. So what's my denominator? It's going to be 6 still. Ever see a dice with more than 6 dots? 6 is not more than 6. 6 is equal to 6. I'm looking for more than 6. So that means, not gonna happen. 0 times, right? So let's see where it rolls out. If it's 0, 6, anytime 0 is the numerator and it has a denominator, if it has a 0, that means the chance is impossible. So moving away from chance and taking a look more at probability, the big thing to remember, chance are the words impossible, unlikely, likely, or certain. Probability is the fraction. So let's take a look at this problem. A bag contains 5 red marbles, 3 blue marbles, 2 yellow marbles. Suppose we pick 1 marble from the bag and they want to know what's the probability that the marble will be blue. Well, works like any other fraction. First of all, we better figure out what my denominator is. So it says we have 5 red and 3 blue and 2 yellow. So let's get these guys all added up right now. 5 plus 3 plus 2 more. That sounds like we're talking about 10 to me, right? So my denominator's gonna be 10. Probability is a fraction, so we better go figure out my numerator now. And they want to know that the probability that it will be blue. So what is the number of blue marbles? 3. So my probability of picking a blue one is 3 out of 10. I know it looks like 3/10, but if it's probability, we're going to read it 3 out of 10. That means you can pick out marbles 10 times, and chances are at least 3 of them are going to be blue. So now that we have that figured out, find the probability that the marble is not blue. So the denominator, fortunately, will still be the same because I'm talking about 10 marbles. But how many of these marbles are not blue? Well, you had 5 red ones, right? And it also looks like you had 2 more yellow ones. So what's the probability that it's not blue? 5 plus 2 more. Hey, that sounds like 7. So the probability is 7 out of 10 times. If you picked a marble out of the bag 10 times, 7 of those times, it's probably not going to be blue. And probability, one more time, is written as a fraction. So check out this one. Ben made a spinner that showed equal probability for 3 different outcomes. Which spinner do you think he made? So a couple of things. Equal probability. That means each one has to be equal. And 3 different outcomes. The spinner can land on 3 different things. Well, if the spinner has 3 different outcomes, I don't think it can be this one because, man, that spinner shows 4 different outcomes. Now we have to look over here. Equal probability. Is this guy equal? No way. C is twice as big as A and B. No way can it be this one. Same thing over here. A is twice as big as B and C. They're not equal. The one that shows 3 equal possible outcomes would be right here. A, B, and C are all equal sized outcomes. Check out this one. The spinner is divided into 6 equal sectors. What are the possible outcomes? And when they talk outcomes, they want to know if you spin it, what can you get? Can I ever spin this and get P as an outcome? No way. I can spin it and I could maybe get an A. I could maybe get a B for an outcome. And I could possibly end up with a C for an outcome. Those are my outcomes, either A, B, or C. So let's check out this. What's the probability? Do they want a word or do they want a fraction? Hopefully you know they want the fraction for probability. What's the probability that the spinner will land on A? Well, let's take a look. How many total pieces do I have here? 1, 2, 3, 4, 5, 6. So if probability is a fraction, my denominator is 6. How many A's do I have? I have an A there, an A there, and an A there. So I can say my probability for A is 3 out of 6. Let's try the probability for B. The denominator's not going to change. I still have 6 possible outcomes. But how many B's do I have? I have a B here and I have a B here. So that means my probability can be 2 out of 6. For every 6 times I spin it, it's probably going to be B 2 out of those times. And our last one, let's go and take a look at C. The denominator does not change. I still have 6 possible outcomes. How many C's do I have? I have 1. So my probability of spinning a C is 1 out of 6. That means every 6 times I spin it, it's probably going to land on C 1 time. So let's take a look at this one right now. Here it's going to go and say that for the spinner, Chuck said the probability for an A was 1/2. Do you agree with them? And tell why. Well, I thought we just got done saying that the probability for A was 3 out of 6. That's what we just got done writing down there. We said probability for A was 3 out of 6. But this guy Chuck is messing with the system. He says it's 1 out of 2. Do we actually agree with them that 1 out of 2, even though our teacher just got done saying it was 3 out of 6? Well, isn't 3/6 equal to 1/2? If I took all these pieces here, these A's, that is equal to 1/2, right? So let's take a look. What are we going to say? Yes, we agree with them. Why? Because 3/6 does equal 1/2. And coming up to the last one here, it says, if you spun the spinner 10 more times, about how many times is it likely that it's going to land in sector A? Well, we just got done saying that A was equal to 3/6 is what we said first. But We also said that 3/6 is equal to a half, right? 1 out of 2. So if I'm going to spin it 10 more times and my probability is 1 out of 2 or a half, what's 1/2 of 10? 5. Probably 5 more times it's going to land on A because the probability is about a half. Half of the times I spin the spinner, it's going to land on A. Half of 10 is 5. And that is the end. Not sure if you're going to need too much in the way of scratch paper and pencil for a Socrative quiz, but you're probably going to want your book open. All right, good luck.